Hello, welcome to the 11th Bevy Meetup. This is super exciting tonight after the heat wave in Europe is finally over to not have to sweat doing this. Let's get to the introduction quickly. This is the 11th time already. We have again two amazing speakers tonight from the Bevy community. The talks are going to be roughly 15 to 20 minutes each, and we're going to have reserved time for some Q&A. There's this Q&A QR code at the bottom corner. So feel free to join in the conversation, ask questions, vote for questions of others that you're interested as well, and try to participate with us here. This is like a collaborated effort. Of course, as usual, everything is going to be recorded and live streamed. So if you have to drop off or if you are joining in later, don't worry, you can always watch it in hindsight on YouTube as a recording. The typical Rust code of conduct: please be kind, be respectful, be curious, ask questions, reach out if you have any concerns. You know how to reach me. And yeah, quick introduction of me. I'm Stefan. I'm doing Rust since 2017, Bevy for 3 years now. I'm doing game development already for 18 years. You might know me from my open source projects of Git UI and LifeAsk. And yeah, recently founded Rust Unit, Rust Consultancy. And please check out our website for more information about that. Here's the QR code for the Q&A platform. It's going to be on the left bottom corner for the whole time. So feel free to use it and ask questions there. And yes, without much further ado, let me actually put our first speaker of tonight on stage. Jan is no unknown to you guys. He is very active in the Bevy community and recently made his Bevy Jam contribution game to reach top 3. So this is super exciting. Jan, welcome on stage. Nice
Hello,
to
everybody.
have you. Let me get your slides and then make room for you.
Yeah, just tell me when
the stage
it's
is
ready.
yours.
Okay. Hi, everyone. Thank you very much for attending this talk, especially the Americans under you. I can imagine that you have quite a few things to do right now for 4th of July and whatnot. I don't know. I only know that tradition from movies. Well, today we're going to talk a little bit about 3D games and how I like to make them. But first, why should you care about what this weird dude has to say? Ooh, what happened? Help! Sorry. I bumped into my mouse. Okay, attempt number 2. Why should you care about what this weird dude has to say? Well, as Stefan said, I am quite active in the Bevy community. I've been using Bevy for about half of its lifetime now. And since like 1.5 years, I am also a contributor. I also use Bevy for my quote-unquote day job. I'm in academia, so it's not a job, but it's my master's thesis. So I get to have an excuse of why I can be in the Discord all day. I also wrote a whole bunch of crates over the years. Crates.io tells me it's about 12-ish, give or take, depends on how you count them. That is Bevy-specific crates, I mean. And I want to just quickly show you a few that are relevant to this talk. First of all, the most well-known one is Foxtrot, sitting at nearly 800 GitHub stars now, 700, 800, something like that. This started off as an attempt to do a general 3D game template for Bevy, and it's kind of derailed into this general dump of, okay, here's all of my knowledge of how 3D is supposed to work in Bevy, just at one place. It's also a really good stress test for the Bevy renderer. So far, I believe I have opened like 5 rendering-related issues that I have discovered with Foxtrot. It's great. Next up is Yarn Spinner. If you've ever used C# before, you might know this tool already. So a few years ago, some cool people made a game called Night in the Woods. And the programmers behind the dialogue drivers, they spun off their dialogue technology into an own tool called Yarn Spinner that is nowadays very well known in the Unity community. And I ported the whole thing to Rust, and the Yarn Spinner people were friendly enough to allow me to put it onto their repo and their socials and whatnot. So if you're interested in doing narrative-driven development, I can recommend you take a look at Yarn Spinner. And lastly, our latest project, this was Chain Boom, which won place number 3 in the Bevy Jam 6. So if what you're seeing on the screen right now looks interesting at all, this is exactly the kind of stuff that we will be talking about. All right. This is the most important slide for today. I'm not going to go into detail, but this is for you sitting at home later on looking at the recording. If you want to get into 3D and you have no idea, like, okay, which technology do I use? Well, I have some good and bad news for you. The bad news is Bevy is not really capable of doing full 3D games on its own yet. But the good news is there are excellent community crates for all of this. And here's my current technology stack. We'll take a peek at the most important ones today, but we do not have the time at all to go through all of this. Just know that if you need some reference for which technology to use, take a look at this cheat sheet. All right. So before we talk about the 3D project itself, we first need to create the project. And I highly, highly recommend everyone out there use the Bevy CLI Alpha for this. This has been cooking for a while now from the CLI working group, and it's planned to be upstreamed bit by bit. So I hope that this will happen soon. For now, you need to enter this fairly long command because it's not, as I said, it's not upstreamed yet. So for now, you enter the long command here to install it, and then you get this Bevy CLI. And you get access to the Bevy new command, where you enter the name of your project, and you get to select a template. And there's a couple of templates that you can use, and I want to highlight the 2D template. It's called Bevy new 2D, and you can look at its GitHub page for a ton of documentation. Cards on a table. I helped contribute to this. Substantially. So I'm biased. I'm really, really biased about this. But in my opinion, we did quite a good job at showcasing everything here. Very important for you out there. This here shows you how to organize your Bevy app. I've had many people over the years ask me, okay, cool, I know how to do single examples and whatnot. How do I organize a full game? Well, here's the answer. And there's also a nice design document that you can read up for more organizational patterns. Again, I will not go through this like in a lecture. Look at this in your own time. I can highly recommend it. So let's show off how this works. So what we do now is Bevy new. I'll call it cool project. And we use the 2D template. Now I've already pre-compiled it here, so we don't need to wait. But just imagine I hit enter now. There we go. And it will generate this little template here. Now, just as a very quick overview, what this shows you is different screens. Now, screens are like things that occupy the screen, a loading screen, a splash screen, a gameplay screen. And this is used with Bevy's state management. So if you've ever heard about Bevy states and you weren't quite sure what they were useful for, this is what they're useful for, to handle transitions between, okay, this was the title screen and now is the gameplay screen. Then we have some UI building blocks over here and some menus that I built of them. But the important part for today is this demo folder, because this here is where the quote unquote gameplay happens. And I'll quickly show you what this has. We'll run Bevy run. And this here is the game. Now, if you've played some of the Jam submissions, this will look very, very familiar to you because a lot of people use this template. But let's head into play. And you can see that we have this cute little ducky here that we can move around. And that's all the gameplay there is, because you're supposed to put in the rest of the gameplay. Another thing that we have is a pause menu with settings where you can drop in all of your settings. This is super important for accessibility. And you can quit to the title, restart the game, whatnot. All right. You might have just seen that I entered Bevy run, and probably a bit puzzled why I didn't just do cargo run. Well, the reason is that with Bevy run, I can pass in the web argument. And you'll see that this does some mumbo jumbo here. And now it hosts our game over here. And now, let me just restart it so you see there's a spinner and a splash screen. And now you can see that the whole shebang is running in our browser. And this here is my favorite feature about the Bevy CLI and why I really warmly recommend it to everyone out there. If you're doing 3D or not, you have to know about this, because this is not specific to the 2D template. You can just do this with every Bevy game. Just do Bevy run web, and it will run in the web. If your code also supports web, that is, obviously. But a surprisingly big amount of Bevy things are just like working out of the box for web. So give it a try. If you have a Bevy project, just do Bevy run web and see if it runs on your browser. 2D template also has a nice release workflow that then pushes all of this automatically up to HIO. Good. So far, so good for... Let me just quickly move something away from my screen. There we go. That's for the CLI. But now let's get into the 3D part. You have noticed that I've only talked about 2D so far. That is because, as I said before, you need a lot of third-party packages to get 3D really, you know, I'm not going to say running, but at least to a stage where it's nice to work with. And the most important one that I want to share with you today is Trench Broom. This is a screenshot of Trench Broom where I'm editing the level as seen in Foxtrot. Trench Broom is a level editing software that was developed for Quake, to make custom Quake maps. But over the last few years, it's become more and more open and cross-platform and whatnot. And quite a few developers are nowadays using it as their primary level editor, especially in the Godot space. Quite a few people use this. And there's also some excellent Bevy bindings. But before I get into the weeds of how to set up Trench Broom, I first want to show you why you should be excited about it. So let me quickly do this. So when you open Trench Broom and start a level, this is what you're greeted with. It's just a little floor over here. This is a texture that says no texture, so this will be completely invisible. I've already set up some textures here, so we can change this to a brick texture. And you will notice that the bricks are automatically tiled for you, which is nice. I've also gotten some example textures here. And if you want to extend this floor, you can hold Shift and move it like this. And you have to know that this block of geometry is called a brush. Now, when I first heard about brushes, I was a bit confused because I thought about painting brushes, you know. But yeah, this is just what it's called. This is a brush. A brush is just a general convex polygon that is solid. Well, generally it's solid. So if we loaded this into Bevy, we wouldn't see anything because there's no camera, but I have prepared this little player capsule for us. So let's plop it into the world. And now I have prepared this little adaptation of the 2D template. This is nearly the same as the 2D template from before, but there's also this third-party module that you can look at to see all the dependencies that we're on. I have open sourced this, by the way, but I will link it later as well. And inside the demo folder is our code for the player handling, level loading, things like that. Let's just run it. And you see that we are on this brush that we created before. Now this is a bit boring so far, so let's also create a little wall in here. Let's make it about this tall. Again, this is not a Trench Broom tutorial. I just want to show you why this software might be useful for you. Let's give it a different texture. And now we can reload the level. And we have this brush over here. You see that it's solid. We cannot move through it. And that's good. Now I'll show you some more things of how this might be useful for prototyping. Let's do a second wall over here. Let's rotate it a bit so we get a nice little slope. There we go. There we go. Now the player is already on top. Let's move him back here. And let's extend this. Again, we can quit to title and start it again, and it will hot reload our level in very, very little time. And now I also want to show you, okay, we can place geometry, but that's not all we need. We also need some entities to populate the world. And I have prepared for us today some crates over here, some wooden crates. And I will reload the level, and you can see that we have the crates, and they are also physics enabled. You can see I can push them a bit around. Not sure how well this is visible when you're not playing it, because the player is stepping on the crates. But yeah, oh yeah, you can see now that it moved a bit. And finally, I can also place a. Let's take the point light. I can also place a point light, and I'll set it to show shadows. Again, reload, and there we have our very, very beautiful point light. Okay, now what this is supposed to show you is how quickly I was able to iterate on this level. Now, there are many ways to do 3D levels. I used to work primarily in Blender before I switched to Trench Broom. Blender is also fantastic software, but my experience, you cannot get this level of iteration speed with something like Blender, because there's just too many steps involved. However, here I just squiggle some walls, and they're here. So this is perfect for iteration speed, which is why I very, very, very warmly recommend you all to look into Trench Broom for 3D levels. Yeah. So I hope this convinced you that Trench Broom is kind of cool. So the next question becomes, okay, very cool. How do we use it? So the crate that we use for this is called Bevy Trench Broom, and fair warning, there's a lot of boilerplate in it. Very sorry about that. I may want to contribute at some point in the future to reduce the boilerplate, but right now it's a bit wordy. So we'll go through this step by step. I have pasted for you the most important code into these slides. So, and it's also on the repo. So if you want to play around with it, take a look at that. First of all, what we do is we add the Trench Broom plugins, and we pass the name of the game in here. Here, our game is just called Presentation because I'm boring. And then we also need a startup system. Here it's called write Trench Broom config. And what this does is it writes down our game config into the global Trench Broom directory. This is necessary in order to make sure that Trench Broom knows about your game. Otherwise, it doesn't know which kinds of entities or models you want to load. And then finally, we need to register this weird struct called world spawn. Now, world spawn, it's a bit of a weird name. It comes from Quake. It needs to have exactly this name. This is the entity that governs how our default brushes are gonna work. Now, this is a magic incantation here. You can ignore that. But the important thing here is this spawn hooks attribute. This tells Trench Broom what to do when it's spawning these brushes. In this case, what we do is we tell it to smooth by default angles. What this means is that if you have some very flat angles like this, it will actually round them down, which is very nice when you're trying to make something like an archway. So you can make it kind of jagged in Trench Broom, and it will automatically be round in Bevy. And then the last thing we do is we tell it to generate convex colliders for this. I have enabled the avian backend for Trench Broom. So we'll use avian convex colliders. And once we have that, we still need to populate the scene with entities. Here, I'll show you the definition of the crate entity. Now, this doesn't have anything to do with Rust crates or anything. This is the wooden box crate. Okay. Again, a whole bunch of magic incantations up here. This is important. This tells you where to find the GLTF. And here in the spawn hooks, we even have a nice option to preload the GLTF when the game starts. And then once the crate is spawned in the world, it just gets added as a marker component, and you can react to it with a regular old observer Here, what we do is we get this path that we gave the model up here. We get the path here. We convert it into a scene. Then we can spawn it as a regular old scene route. And here, if you have ever used Avian, this will look very, very familiar to you. We would just tell it it's a dynamic rigid body. Here we have a collider constructor hierarchy. If you've never used this was really nice. What this does is it goes through a scene, through all of its children once it has loaded. And for all meshes, it will generate a collider for this mesh. In this case, it generates a convex hull. And we also tell it to generate it with a higher density than the default, because the default is 1 kilogram per cubic meter, which is very, very, very light. So if we left it at the default density, if we ran into a crate, it will just fly all over the screen. We don't want that, so we increase the default density a bit. Okay. So that was my quick, short, and dirty introduction to how to use Trench Brew. You've also seen that we were controlling the character. We do that with a character controller called Tenwa, but you can also use your own character controller, depending on how in-depth it is. This might be easy, this might be hard, but there are many different options for how to do character controllers. So we won't go too much into depth of that. But the important thing is that I want to highlight this crate called Bevy Enhanced Input, which is slated to be the upstream successor of Bevy's current, well, kind of non-existent input handling. So I'm seeing that we're running out of time already. Time flies. So let's get through this a little bit quicker. What this does is you define a little context here, an input context. In this case, it's the context for the player. And then on this input context, you have different actions. Now we have in our demo 2 actions, move and jump. And then we bind these in this little observer. Again, look at this in detail on your own time. But basically we just say like, okay, this is WASD for move, and we use a left stick on a gamepad. There's also some modifiers here in order that we get a vec3 as an output. So we get directly a direction in which we want to move. And the same for the jump, but the jump doesn't have a vec3 as an output, it's just as a boolean. Did we jump or did we not jump? The reason why we use an input context here is that if we, for example, want to enter a vehicle, then the vehicle controls will be very different from the on-foot controls, and you can do this by swapping out the input context. Now, of course, in this case, we only have one input context. And then our actual input are triggers, which means that you do not need to care at all about scheduling these, because if you use a 3D physics engine such as Avian, actually updating your character controller in the update schedule is wrong, because the fixed schedule runs before that, and actually you get a 1 frame delay, and you don't need to care about any of that, because Bevy Enhanced Input just handles its scheduling for you, and you just handle your movement whenever this observer gets triggered. If this sounded interesting to you, some further reading that I have prepared for you, here is the official first-person view model example that I contributed some while ago. This one shows you how to correctly set up cameras in first-person contexts, because in our demo, we didn't have any hands for the player. But if we had hands, this would be called a view model, and usually that is rendered using a separate camera. If you want to learn more about how and why that is done, look at that example. If the things that I just talked about, like scheduling and fixed time steps, sounded somewhat interesting, you should take a look at the fixed and physics in a fixed time step example that I contributed. There's a lot of information there that is highly relevant to 3D games. And you can also take a look at Foxtrot source code. Again, like, don't try to understand the entire thing. It's huge. Just if you care about cameras, look at the camera code, and then try to steal whatever is useful for you. Okay, I think that was all in the time we're given. Yeah, thank you very much.
Awesome, Jan. Super exciting. Finally, seeing more about people using Trench Broom for 3D games and Bevy. So some questions that were coming up. Let's first one actually quickly out of the way. How did you come across Trench Broom?
I think the first time I learned about it was a whole bunch of years ago when I just Googled how to level editor and I just saw a bunch of them and I saw, Trench Brew, this looks old, I don't want it. So I just immediately dismissed it. I got more interested in it from watching different devlogs by other people, and I came across this great devlog by a developer called Blargis that develops a game called Blood Thief, where he talks about his how enamored he was with Blender as a level design editor, and how he created all of these pipelines, and then he threw them all in the garbage once he learned about Trench Brew. And I felt very challenged by that because I was in the same situation. I also had my custom pipelines for Blender, and I was very protective of them. I didn't want to throw that away. I was like, okay, if someone else threw away all of their Blender stuff in favor of Trench Brew, maybe I should look into it once more.
Yeah, but did you at the time know that it was already that there were crates, or how was
then
how did it?
There was another
right.
crate for it back then. It was called Bevy.
Nice.
But yeah, it's no longer relevant now that we have Bevy Trench Brew, in my opinion.
All right. So the mostly voted for question is, what would Bevy need to be at a stage where general 3D games such as RPGs, city builders, etc., are feasible to be done with it? I guess. What's your take on that?
The number one thing that we absolutely definitely need before we can talk about any of this is collision detection in tree, because like right now, like you cannot do it, right? So even if you don't use physics, even if you just want to have some kind of, if you play Zietler, you will have some kind of pathfinding in it, and for that you need to have some kind of collision detection, and for everything beyond that, you also need to have some kind of physics. So yeah, my number one thing would be a physics engine. Now, if you're following the Bevy physics space, then you will know that Avian is the go-to right now. And there's like this huge tracking issue that me and the creator set up a while ago about like what is missing in order to upstream Avian. And the current estimate for that is like, we might be there in 2 to 3 years. That's like time frame. And
why is it necessary to upstream it?
Well, to have it in a upstream doesn't mean like take it, copy and paste it. It's just like, okay, at this point, it's good enough as a reference implementation of how to do ECS ready physics that we could either like copy paste it, or we could create our own thing looking at Avian for guidance. Because as you're aware, there are not many ECS only engines out there. So the whole physics space in terms of ECS is pretty much unexplored. So yeah, having some kind of feature-ready implementation is very, very valuable for that. Because you don't want to have breaking changes in your physics engine too much. So that would be very bad.
Is there even any reference physics engine driven by ECS at this point? Like other than Avian and Bevy?
You mean what? Sorry?
Is there even any other physics engine driven by an ECS out there aside from Avian?
Well, the Rapier integration layer, right? But there's also the Unity Dots physics. I don't know how to call it, compatibility layer. Like, Unity Dots has some weird things about which things are ECS and which ones aren't, but I'd say that one is the major one. Yeah.
Is that open source? Is that something we can learn from?
I don't think it's open source, but though the last time I looked at it, Unity's licensing and like things were very different. Very different.
Okay, let's move on to the next question. Could you make it hot reload the level in place? Because I think you always had to go to your menu and reload, right?
Yeah, definitely. That's just a bug that needs to be fixed in Bevy Trench Brew. I was just not bothered enough by it to submit a PR. But yeah, you can definitely do that. Yeah.
Right on. Nice. Okay. Do you know other active Bevy game projects using Trench Brew?
Well, I know that the users, I don't even know their real names, but I got on GitHub, they're Periwink and Brian H. They are using Trench Broom for a multiplayer thingy. I think you, Stefan, told me that Corey was using Trench Broom as well, right?
Yeah, for Varg. Yep.
For work, yeah, exactly.
Yeah.
I've seen also some people just like post little progress screenshots of their thing, and I don't know how far they are, right? I didn't see a name. It was just like, oh, cool, you made this in Trench Brew, right? And they were like, oh yeah, Trench Brew is cool, right? And we're like, oh yeah, and then that was our interaction. So yeah, I don't think it's like at a level of popularity where you could say, oh yeah, there are like hundreds of projects. No, it's not that. I would say it's still niche. But if it wasn't niche, I wouldn't be talking about this right now. I would be like, yeah, you all know Trench Broom, go use it. But the cool thing is about Trench Broom compared to something like the Blender interactions, as great as they are, is that the Bevy Trench Broom integration layer is very, I'll say, transparent. Like it goes away very quickly. So in Trench Broom itself, you're not doing anything that is Bevy specific. And that is a great sign, because that you could just look at, first of all, it means that even if Bevy Trench Broom gets abandoned at some point, it will still work. There's no Bevy specific stuff in there. You just have to bump the version, basically. And second, it also means that you can use all the tutorials and knowledge and whatever that people have done for Trench Broom over the years, whether it is Godot users or Quake mappers or whatnot. So even though there's not that many people who are actively using Trench Broom right now for a Bevy, I feel very comfortable in recommending it.
Yeah. I mean, especially the Godot case, I think, is important, because that's probably also requiring a lot of like how you bind Godot specific classes or whatever it's called there to entities, which would be pretty similar, I assume, to how it is done with Bevy Trench Broom.
Yeah, definitely, yes.
Right. Okay. You know what? I will leave the remaining questions for later, and we're going to move to our second speaker, and then we see each other at the end for some panel conversation together. Is that okay?
Great. Yeah.
Awesome.
Thank you again,
thank you so
everyone.
much. Big hand for you, and see you in a bit. All right. So now it's time for our second speaker tonight, and this is actually referencing a job offering that was recently put on or found by someone in the Bevy community and put into the Discord, linking to a company that is publicly claiming to be using Bevy and looking for a job profile of folks with Bevy background. So I'm super excited to have Alix here tonight. To tell us a little bit about what Metabuild is actually doing with Bevy. So let's give a big hand to Alix and welcome him on stage.
Hello, everyone.
Alix, let me put your slides up here, and then I'm gone. The stage is yours.
All right. So today I'm going to talk to you about how we're using Bevy at Metabuild to create a building design application that runs in the browser. So just a quick word about me. I'm Alix. I've been working at Metabuild for about 3.5 years. And during that time, I've used Bevy to create or to contribute to the app I mentioned, and also Rust for various other parts of our infrastructure, such as, for example, setting up lighting simulations and other things. So what we're doing at Metabuild is we are creating a platform, an online platform for real estate developers so that they can create digital twins of their buildings. And the platform will automatically determine the best possible renovation timelines for their buildings so that they can fulfill the various regulations regarding CO2 emissions, energy consumptions, thermal and lighting comfort of the occupants, etc. So the way our platform works is that basically you start by creating a baseline model of your building with our app. there are basically two scenarios where our app is useful. Is basically either you have an existing building that you want to renovate, or you have a new building project, in which case you just want to see improvements upon your current design. So you start by creating the baseline, and then we can then simulate a bunch of properties of that building regarding daylight, thermal properties, electricity consumption, energy consumption, etc., and generate a bunch of scores based on building standards in order to evaluate the building. And then we have a process that basically is an optimization where we generate 1,000 variants of that baseline. So in the case of renovations, these variants will basically be renovations in specific years in the future. And in the case of a new building, there will just be improvements upon your design. And at the end, you can get, of course, generate a bunch of analysis reports, performance certificates for the buildings that pass them, etc. And this whole thing is a fully configurable process, so you can adapt it to local regulations as well. So where we're using Bevy, finally, is our modeling applications, as I said, which is a core part of our platform. It runs on the web, and we can use it to draw and configure building models as well as visualize the analysis results. So I'm going to do a quick demo of what it looks like. That's what it looked like. Basically, you can see we have a little map render that uses data from OpenStreetMaps. You can either start drawing a building manually in 2 dimensions, or you can just use one of the existing buildings here from the map. We have a little wizard where you can configure a bunch of things, specify where you want to see which walls should have windows, that kind of thing. This is mostly just a helper, as you can also do everything manually. And then you can, basically it's a design application, right? So you can change a bunch of properties. You can change stuff in 3 dimensions or in 2 dimensions. The building is composed of a list of stories, right? And every story has its own floor plan with the walls. The walls are represented as a graph. And you can, of course, draw a bunch of things. And there's also a pretty extensive sidebar here where you can use it to navigate between objects. So this is all powered by custom relations. Not really using the default Bevy relations, unfortunately, because we started this before they even were in Bevy. But yeah. Then, of course, you can run the optimization process that I mentioned in order to find rate a bunch of different variations. And you can also use the app to visualize some of the analysis results. So this is, for example, an analysis result of daylight simulations. This shows the illuminance that the different spaces are receiving throughout the day, averaged over a whole year. So basically, our data model is composed of 2 things. There are objects and settings. Objects are just buildings, stories, windows, walls, that kind of thing. And settings are properties that are assigned to these objects. So construction materials for the walls, shading systems for the windows, usage schedules for the spaces, etc. As you saw, the stories are composed of a graph. It's actually a half-edge graph, to be specific. There's one for the walls and one for the roof, which also has height information in order to create all kinds of crazy roof shapes. And the graphs are both entirely contained in the ECS. So vertices, half edges, edges, and faces are just entities, basically. Our model is defined in a dedicated crate with its own Bevy plugin. We call it the Beam plugin. And it defines objects and settings using entities. It's fully headless, so there's no visuals and no interactivity, because then that makes unit testing easier. We can test a bunch of things without having to worry about those things possibly breaking, and it just separates concerns better. For saving and loading the model, we're just using the standard Bevy's dynamic scenes to serialize the model to JSON. And then we have a separate dedicated type registry, which only contains the model components and resources. Of course, when we evolve the model, we have to add fields to components on this kind of stuff. So we have a migration process, which is really simple. We just basically store a version number next to the scene. And then we have a bunch of functions that are whose role is to just migrate from one version to another. One kind of one pitfall to avoid is in the functions that migrate the model, you shouldn't deserialize the JSON values to types, because if you do that, then you're going to have to keep those types around forever, and we obviously don't want that. Another interesting aspect that the Beam plugin defines is there's this issue of having some redundant calculations, right? For example, here, if I want to know the elevation of the floor of story 2, I'm going to have to basically just sum up the story heights of the stories below. Simple calculations, but it does require me to query more entities. One solution to that could be to use a system param. But if I do that, then it's going to be recomputed every time, and it also borrows more entities and more components, and there's a better solution, which is to basically just add extra components and entities on top of the model. These, we call them the cached state. And we don't store them in the scene, obviously, because we can always just recompute them. And a nice bonus of this is that it makes change detection easier. For example, here I can just use the changed query param with the floor elevation component that we add on stories, and just do change detection with that directly. A quick note about how we actually implement the interaction and rendering. We need both 2D and 3D representations of the same BIM objects. And for this, I recommend just actually having separate entities. If you need this, you can have separate entities for both representations, with one plugin responsible for each, and that makes things easier, because you can't really have 2D and 3D representations on the same entity with Bevy. For UI, we're using Bevy GUI for now, even though, of course, we're really excited to see how Bevy UI evolves, especially in the coming releases. And the way we're doing it is basically all the top-level containers, like the sidebar and header and footer. They are basically just an exclusive system that creates the container, and then inside the container we call a Bevy schedule. So for the different, if you want to add some new content to the sidebar, all you have to do is just to add a new system, a new system to the sidebar schedule. And of course, you have to make sure that you order it properly with the other systems. But yeah, it's a pretty simple way to do it and really convenient. We just insert the UI struct from eGUI into the world when we do that. Now I'm just moving on to some random things that we learned along the way while building this. One thing is especially with application like this, which is pretty geometry heavy. It's super important to have good debug tooling. So it's a good rule of thumb to just add a bunch of buttons somewhere, hidden somewhere, that you can click that will visualize things about your scene. Especially while we're still waiting for the editor to pop up. But yeah, other valuable tools is Bevy GUI inspector, which you can use to inspect your scene. I mean, it's pretty well known nowadays in the Bevy community, but you can see all of your entities and resources and assets and inspect them, modify them. That's really useful. And another one is Bevy mod debug dump, which shows you graphically displays a graph of your schedules, which is really useful when you have system ordering ambiguities and you want to track them down. One constraint that we have is we want to be able to run our app on a laptop that is on battery. So there is a when it's setting resource in Bevy that lets you change the update mode to reactive. Reactive mode basically just avoids updating the app if there are no input events. So that's something that we want. But we also have animations, as you may have seen when you remove the camera. The camera takes a bit of time to actually come to a complete stop. And so we have to switch, we have to be in continuous mode most of the time, but when no interaction happens anymore, we wait a few frames and switch to reactive mode. But there's a bit of a pitfall with that, is that when you switch back to continuous, you have to be aware that the delta times that you read in the update schedule kind of lag a couple frames behind sometimes. So when you switch back to continuous, you may see like a sudden jump, and that's just the delta time from a few frames ago where you were still in reactive mode. So it's what we found to be a good solution for this is to set a max delta time for a few frames when switching back to continuous mode. Lastly, some words about running on the web. Unfortunately, WebGPU is still not fully supported on all browsers and platforms. And unfortunately, we also saw some bugs with WebGL2 implementations on some platforms and some browsers. Our solution ended up just being compiling the app twice, one with WebGL2 and one with WebGPU, and we just use a bit of JavaScript code to select between the two based on what is supported. Another kind of headache with the web is multi-threading. So you have to use web workers, which are basically just a separate binary WASM that runs in a separate thread. And for this, you can use the glue worker crate. It has a nice little API that looks like calling a function, but it's actually serializing the arguments and passing them to the web worker. But unfortunately, because it's serializing arguments, it's a bit there's an overhead, so it's a bit slow. And another crate that you can use is WASM thread, which has an API similar to the STD thread, so more convenient, but unfortunately it requires nightly and some extra compiler flags. So yeah, still experimental. And last thing is the WASM32 target has a maximum memory usage of 4 GB. So in that case, the solution is just don't use more. But yeah, it's good to be aware of it. And there is an alternative target, WASM64, in the Rust compiler, but it's still in support tier 3, so it's not a first-class support, so it's still experimental. Last closing notes is if you find this interesting, we're hiring, so feel free to get in touch. I'll be happy to answer any questions.
Hey, Alex, super. Thank you so much. That's super exciting to see Bevy in production on the web. So as you can imagine, there's a lot of questions regarding that specific aspect of it. So let's dive into it. Do you have some pro tips to reduce the WASM size? How big is the client at Metabuild?
Oh, it's actually pretty big. It's pretty big, but we're doing some caching, so you only don't download it once. But yeah, there are some ways you can reduce it. There is WASM opt, which is a tool that just takes your WASM as an input and applies some optimizations to it to reduce the size. And obviously, there's also I think a flag that in the cargo tunnel there are some flags that you can set. Forgot exactly. Yeah.
But what size are we talking about in your case?
Good question.
Roughly?
I can I can look at it and tell you directly. All right, let's.
Well, that.
That works. Okay. Yeah, pretty big. Yeah, 182 megabytes. That's
wow.
a lot, obviously. But
and
yeah,
that is just one of the two rendering types.
Yeah. So
oh wow.
Yeah, but we only don't download one of them, of course.
Yeah.
But,
yeah. Okay. So the JavaScript magic decides which one's appropriate.
Yeah, exactly.
Okay.
Yeah. But the caching is super important because otherwise the loading times would be absolutely horrible.
Yeah. All right. The next question is, how does this differ from Autodesk Forma, and what does it do better? I have no idea what that is.
I don't really have experience with it, to be honest.
Okay.
But I know that one of our guiding principles in terms of UX design was mainly to actually reduce the just make things easier as possible and incremental. So I don't know how it compares to that specific app, but what we try to do is to make it so that you can start with a really, really basic model to get started somewhere, as you saw with the little wizard tool. And then you can just incrementally add more and more specific detail to your building. And we try to hide as much of the complexity as possible. So yeah.
So it's about ease of use, user experience, simplicity.
Yeah, exactly. Yeah.
All
we
right.
try to make it as efficient as possible.
And I mean, I'm not sure because I don't know this thing, but I'm assuming Autodesk Forma is not running in the browser. But yeah.
Yeah. I'm not sure.
The next question is, why switch to continuous rendering and then back instead of sending request redraw events during animations? Well, that sounds like a question Francois would ask.
That could probably be done as well. I mean, I guess we started from continuous mode rendering and later realized, of course, we don't want to always update, so we had this little switch. I'm not sure. I haven't really tried sending manually those redraw events, but maybe that could work as well. Yeah.
There's actually another question that's pretty closely related. How do you detect the animations that animations are running to then be in continuous mode?
We're cheating. We just wait for a constant time after you stop pressing. I mean, we have a we basically have a system that queries a bunch of possible sources of animation, like the camera, and if the camera transform has changed, we have a little timer that will be set back to 0. And after a while, if nothing happened, we switch back. Yeah.
All right, got it. So that's the only type of animation that you're currently considering there, the camera movement.
We have a few more. Don't remember exactly.
Okay, but it's similar. Yeah.
Yeah, it's still one system that It's like querying for all these possible sources of movement.
Okay, got it. The next one is about backends. Is this thing talking to a backend? What is the API or data model like? And are you using any crates for this?
The backend is just a Postgres database. Our models are made to be like a kind of self-contained. So, for example, we have like the daylight simulations that we have are just another Rust binary that we can run, and it just takes as input the JSON scene of the model. So it mostly just backend is not doing a ton of stuff except moving stuff around. We do actually have a bunch of scripts that are configurable, so you can like add extra scripts to like derive some information from the model and customize simulations and results.
So when you say the backend is just Postgres, are we talking about a REST API that wraps Postgres, or are you talking to Postgres directly?
Yeah, we're using Postgres actually.
Right. Yeah. So that's like a RESTification of a Postgres database, right?
Yeah, exactly.
Okay. Yeah. Okay. Interesting. All right. So next one, is the WASM app all self-contained with local storage in the browser, or does it need to reach out to any external dependencies or infrastructure? I guess the question is, do you use WebSys to talk to these browser-specific APIs?
I think we have a few of those. We're communicating. I mean, we do use WebSys to communicate to the local storage and store some information in there about just the state of the application. Yeah. Not sure if that answers the question.
I guess. Yeah. I mean, is there any other API that comes to mind that you're accessing other than local storage?
Not really. Or at least none that comes to mind. Yeah.
All right.
Actually. Oh yeah, of course. Yeah, the URL is one of them.
Oh, you mean you read the URL the user accessed?
Yeah.
Okay. So that's the workspace ID that I see there, for example.
Yeah, exactly. Yeah.
All right. That's straightforward, I guess. How do you exclude your cached components from serializing? I think you mentioned that these are not put into the serialized scene, right?
Yeah, exactly. You can in the dynamic scene there structs using the dynamic scene builder type, you can add component filters and resource filters, and they are basically, as I understand, they're just lists of type IDs, I guess.
Okay. So that's how you filter them out. You just provide a list of the ones. Do you provide a white list of what you want or a black list of what you don't want?
A white list, because otherwise we would, if anytime we add dependencies, we would have to exclude all of those.
Yeah, makes sense. All right. Alix, let's get Jan in here, because I think there's a bunch of questions that I would also like to hear about him building his project on WebAssembly. But this is your applause here. I'm going to ask Chad to give you a big hands. Thank you so much for sharing what Metabuild is actually working on with Bevy, and it's awesome to see this in production. And yeah, thank you. And I'm going to pull up Jan here too. Hello,
hey, everybody.
Welcome back. Oh shit! What was that? That was the wrong tile. No, don't take it personally. All right. Yeah. So we have two more questions. We had a few more questions for you specifically, Jan, but we also had one for Alix here. Maybe you have something to say about that too. But the question is WASM Thread, that's the crate that you mentioned as well, supported on all browsers? Because you only mentioned that it requires nightly and stuff like that. But would it then run on every browser that you know, or for multi-threading?
I think it requires like WASM Atomics, or it might require some features that are only available. Exactly which one? I think.
Okay.
Yeah. So
maybe not.
Maybe not, but yeah. I didn't see anything specific towards that in the crate description, so I don't think there would be specific browser limitations. But yeah.
I mean, that would be cool. That would be more ergonomic. Sorry?
I just want to say, I don't know anything about multi-threading on WASM, but I can say a thing or two about build sizes in WASM, because I saw like a few questions were like circling around this topic of like, how big is it? How can we make it smaller? Everything like that. So should I talk a bit about that?
Yeah, definitely. Please.
So this is definitely no new topic for me, since our jam submission clocks in at a compressed 20 megabytes or so, which is, it's bigger than we would like, but still at the same time, it's a full 3D game. It's fine. So
that includes, that's just the WASM, right? Or is that the whole assets as well?
That's the whole thing.
Oh, wow. Okay. That's not too bad.
But compression really helps. So even then, before, when Alix was showing his WASM file, server at the end of the day also sends it compressed. So it's not the full thing you download.
Of course.
Number one thing that, according to some benchmarks that me and some others did, that helps with lowering the sizes of your WASM builds is disabling dependencies. I mean, okay, the number one thing is obviously like, don't check in gigantic 3D models, right? But that's trivial. Other than that, disable dependencies that you have. So set everywhere where you have dependencies, set them to optional, and like set default features to false, and just check in the ones that you need. That makes a huge difference. That's number one. Number two is, this is only available on main, but some people did some benchmarks on or some investigations of what the contents were actually of the WASM files, and a lot of that was debug strings. So stuff like system names, function names, things like that, which it's nice, but on WASM you probably prefer to have the size. So on main right now, there is an opt-in feature flag you can disable by disabling the default features that will exclude all of these debug strings, which makes a huge difference.
And they're even in release builds if you are using Bevy 16 now?
Yes.
Oh, that sucks.
It's a lot of these strings, yes. So those are my 2 cents about that.
Did you try the main thing where you disabled that feature? Like, do you
I didn't yet
recollect how
I didn't port my stuff to main yet, but looking at the benchmarks that other people did with it, it was like, woo, okay, that's a lot. It's a lot of strings.
Yeah, that sounds promising. Also kind of curious why this is in release builds, but that's a different question, I guess.
No one bothered to remove those.
Yeah, I guess.
No, if you do #derived debug, then you have a #derived debug. That's available in release, right?
True, of course. All right. But there's actually another TrenchBroom specific question for you, Jan.
Sure.
So Quake maps had baked lighting. Is that supported?
Yes, with an asterisk. So if you know about Quake maps, the stuff that you actually edit with TrenchBroom, those are .map files. .map is a very, very simple format. Just shows you, here's geometry. Very simple, very neat format. What you can do is you can use so-called Quake map compilers. The important thing to Google there is Eric W tools. That's like the compiler people use. You point that to your map file, it generates a BSP file, that is binary space partitioning, and that one has all the baked lighting in it. And you can actually import these BSP files into Bevy, and then you also have baked lighting in there. Now, the reason why I said asterisk is that this workflow is primarily, because these compilation tools were primarily done for Quake, so they also follow the limitations of Quake. And there are some very, very, very annoying limitations there. Like, for example, all of your texture paths, that is not just the name, but also the subfolders, must add up to less than 15, or like equally to 15 letters in length. So,
oh wow,
this is not compatible with how I personally organized my files, you know. So what I did is I wrote a ACID pre-processing script that takes all of my paths and clamps them down onto 15 characters length, then goes into the map file and replaces the lengths with that. And that way it works. I will say though, this is stupid. So this is not the fault of Bevy Trench Brew, but I wouldn't do it. Like, I tried it. It was a lot of work. I got it working in the end, and I wouldn't recommend it. What I would instead do, and I say would in scare quotes because I didn't bother with it, is Trench Brew can actually export your geometry as a .obj file, and you can load this object file into Blender, and then you can use something like PC Walton's Blender global illumination baking workflow in order to bake that lighting.
Yeah.
Now, the reason why I didn't do that should be obvious, because this is all so much setup across different pipelines. In my opinion, baked lighting is just not there yet in Bevy. It all works like in theory.
Yeah, and I mean, with Blender, then you're back to where you started, right? And then also you probably lose all the entity, like the types, the entity classes that you.
That's a very good point. No, you don't, because for Blender, it's just you just have the geometry, and you don't load this geometry for your world data or anything. You're not loading the Blender file. What you do is
just
generate exactly. Yeah. You bake the light into a file, and then you just load the light information. So that's not a problem. Also, like, you're not designing the level in Blender. You're just using it to bake stuff. And you can also, in theory, automate that if you have a baking setup.
Yeah, and if you want to write a bunch of Python.
Exactly.
All right.
You just have to nerd snipe your friends into writing these tools for you. That's the secret advice here. I complained loud enough about environment maps and cube maps, and someone wrote a tool about it. I'm happy.
Good job. This one's sort of related. So can you inherit from other classes like it was possible in Quake? I guess that we are talking entity classes.
Yes, you can. This little base attribute that you saw, you can use that to inherit from other classes. I didn't show it too much because this is it's a whole bunch of boilerplate. But if you know about Quake mapping, you will know about something like point classes and things like that. So in the parlance of Bevy Trench Brew, point classes is something that you place in the scene, like your regular entities, your crates and whatever. You can also have base classes. These base classes, you cannot place them in the editor because they're like abstract, talking OOP terms. But you can inherit from them with the base attribute. You can do that. You can definitely do that, yes.
Can you have, I mean, this is now me following up. Is there, can you build hierarchies like that? Like, can you have a base class, another, and you inherit further? Which means that how is that going to be accessible on the Rust side then, lacking the actual inheritance mechanism?
It's required.
If each of them has properties.
It's just required components then.
Oh, right. Of course.
If you inherit from A, that just means you also have an A on your entity. Yeah. Just make sure that all of these things have fields that have different names, because the Trench Brew editor, that one doesn't know about any hierarchy. It's just like, oh, here's a whole bunch of key value entries.
List all the properties that it would.
Yeah, exactly. List all the properties of the hierarchy. So,
well, that's also one way to solve the whole diamond problem there.
Yeah, you just flatten it there. No diamond there. Like, fortunately, like Bevy doesn't really lend you, like, shoves you the way to do like hierarchy stuff. So this problem doesn't really come up in my experience.
Mm-hmm.
But if you remember, I showed that I put a point light in the scene. I put that in there by just inheriting from the Bevy point light. So this is why it also had all the fields of the Bevy point light in the editor.
Yeah, that's, I mean, regarding the lighting question would have been interesting. How do you actually even place them? So you need to build your own entity that inherits from this lighting thing?
Yeah,
or
I can
otherwise you don't have...
I can very quickly show this on my screen, actually, if you don't mind, because it's very little code. It's easier to just show it than to talk about it.
Sure.
Is my code visible?
Yep.
So I hope the font size is good enough. But this is the code for the point light. So this, you see, base, point light. This is just a Bevy point light. Now I called mine light point. Why is that? That's because Trench Broom uses underscores to group things. You see these things? I don't know. It's a small font, but my lights are called light directional, light point, light spot, and these are all under the light group. This is why it's called light point. But yeah, this is all the code you need to get your light going. It basically just says inherit the Bevy point light, and that's it.
Yeah. Okay. And if you don't define this icon sprite thing, then it wouldn't show up as a proper lighting icon in Trench Broom, or what?
It's just a cube then. It's just a purple cube.
Okay. Right on. Oh wow. Yeah. So I guess the only other thing that I was wondering when you were talking about the BSP format, that also that forces you to actually build these enclosed maps, right? Doesn't it have to be like watertight essentially, or airtight to work?
Yes. The thing is, the compilation step is split into 3 things. One of them builds the actual binary space partitioning. That part doesn't care about watertight. The second part is the light. That one also doesn't care about watertight. The third one builds visibility zones, which the Quake engine uses as an optimization for, saying like, okay, if you're standing here, you can only do these. These things care about watertight enclosed spaces, but they're not used by Bevy Trench Broom. So in practice, no, you don't need to enclose it. That's fine. You can forget about it. Except if you want to flex to your friends that your level can be loaded in Quake, which is kind of cool. But then you need that.
Well, okay, that's a stretch goal. I see. Awesome. So this is the stack that you also used for the Game Jam game, right?
Exactly.
Yeah.
Exactly that.
Cool.
I also have,
so
as a little bonus of something else that helped a lot for the Jam game, I have a little bonus for showing the hot patching stuff, if you care about that.
What exactly?
Hot patching is this cool new feature where your game is running and you're changing the code in the system, and it live patches the running app, which is especially nice for UI because you can just write UI code and the running game gets updated with the new UI.
That's okay. If you have that to show right now,
I prefer that because I thought like this might be interesting for some people.
That's an interesting nugget. Let's have it before we call it a day.
Improved CLI from Dioxys. Exactly. You got that right. This is about the Dioxys stuff. Let me quickly share my screen yet again. Just stop me if I'm taking up too much screen space here. So, all right. So can you see my screen?
Yeah.
So this here is made with Bevy Simple Subsecond System. It's a bit of a mouthful. I'm sorry, that's my bad. But this is our little prototype for hot patching. This is built into 0.17. So for the next release, you don't need a dependency. But if you want to try this out right now, look into Bevy Simple Subsecond System. That repo has all the information for, let me just quickly open the right thing. There, this repo has all the information for how to set this up. So I will not go into detail. But once you have set it up, you can use the Dioxys CLI with DX, and then you do serve with the patch option. And now this will compile real quick. You can see our UI here. Now, can I maybe do it like this, like that? Is that working fine on the stream?
Mm-hmm.
Good. And now you can see that I can just add new texts, and they're in the UI. And as you can see, I didn't restart anything. I can also enable the debug view here and change the texts to whatever, and it hot patches it live. And this is really, really, really good for doing UI. It's also good for tweaking stuff like in our zombie game, we had things like how quickly should the zombie move, how fast should it hit. Things like that were really nice to just hot patch and just see live. But in my opinion, the biggest advantage you get is from being able to do these UIs real quick.
Yeah, that's for sure. I mean, that's because for the other stuff, you can also pretty easily use like asset files that define properties and things like that, right?
Exactly.
That you can easily hot reload. But for UI, this is at this point
precisely. Yeah.
Pretty shit. Yeah.
So the only thing you need to do right now is this little annotation here. As I said, this is part of Bevy 0.17. So if you just want to wait until that, you can forget about it. If you want to use it right now, Bevy simple sub-second system and this little annotation. It just
But you have to manually do that. You cannot just auto flag every system like that.
No, you cannot. You cannot.
Okay.
Again, like this is the important part that is upstreamed.
No, but I mean also with the upstream version, it's going to be required.
Oh no! The upstream version doesn't need anything.
Oh.
The upstream version just has a flag. You just say Bevy, and then you add the feature. I think it's called hot patching.
Mm-hmm.
There, you add the feature, and that's it.
Okay,
the rest
that's pretty dope.
magically works. That's it.
Yeah. Awesome.
Yeah,
how's that?
It's really, really, really cool.
How's that when you change the signature? Does that also work?
It crashes and burns. So there's a couple of caveats there. You can. The thing is, if you change the signature, then the function that is in the V table is no longer the correct one, so it doesn't work. But we have done a little workaround, because this is kind of like the prototyping trait for that. There is a attribute called hot patch signature there, and this one will tell you that you can also change the signature. It comes with new caveats, because then it just wraps your system into a new system that has world access. And what you're hot patching then is the inner system, not the outer system. So a couple of caveats. For example, your locals will no longer work if you do that. So if you have an event reader, that's not going to work. So that one is like, but the version that just works without any caveats whatsoever, just works magically, is this one, where you don't change the signature, you just change the content of the function.
Yeah. That's pretty cool. I mean, that's already a huge improvement.
It's really cool. We wouldn't have been able to do the UI for the Jam game at all without this. Because I cannot change the UI, then play up to a certain state, and then think, oh no, actually this is off by a few pixels. Let me restart the game and then shoot zombies again until I'm at the right state. Yeah, no, that's, you come up with other workarounds then, right? You build a UI testing scene or whatever. Yeah, of course. But that's just like more work you have. And you don't have the time for that. Or at least I don't have the time to come up with all of these workarounds.
No, for sure. I mean, an editor would be another workaround for this. Just saying.
I'm also seeing a comment about looking forward to deriving that baked lighting of Solari. Well, sadly, the author of Solari is not planning on implementing baked lighting with Solari.
What is Solari?
You have not heard about Solari? That's the built-in ray tracer for Bevy 0.17.
Oh, yeah, no, I've heard about this ray tracer proof of concept, but I didn't know it was called like that. Okay.
Oh, yeah.
Yeah, I mean, that would be That would be pretty dope. Yeah.
It would be really nice to have baked lighting in there. So PR is welcome. If you are a GPU a graphics programmer in the audience, you must do a PR right now to do baked lighting with it.
Not my words. Listen to Jan. Awesome.
See, I told you the secret is to nerd snipe other people into it.
That's a good strategy for sure. Okay, do you have any other remaining topics you wanted to talk about? Otherwise, I think we will call it a day now. All right, then thank you both so much. This meetup wouldn't be possible without all these insane contributors from the Bevy community and the willingness to share their experience, right? So I'm super happy and grateful to have you. And yeah, last shout out for Chad to give you a big hand. Thank you so much to be here tonight.
Thank you for having us.
Yeah, thanks. Thanks for having me.
Awesome. Okay, then this is it for the 11th Bevy meetup. Like I said, watch out for the Rust Unit YouTube channel for the recordings that are going to be uploaded eventually. And check out the URL to join our meetup group to always be up to date with new meetups being announced. And yeah, that's it for tonight. Thank you so much for being here, and see you next time.